Hey everyone, welcome to TechWired. In this video, we are going to solve problem number 1129, shortest path with alternating colors. So first, I will explain you guys the problem statement. Then we will see the logic and the code of this particular problem. Now let's dive into the solution. We need to find the shortest path from 0 to all other nodes. Okay, we need to find the shortest path from all other nodes, but these shortest path should be in alternating color edges. Alternating color edges. I'm going to use the BFS approach in this problem. So I'm going to visit, for example, if I need to find the shortest path from 0 to 2, there is a direct edge, right? And there is no previous color seen by the 0. Since blue is the direct edge from 0 to 2. So from 0 to 2, I can visit in one step, like one edge, within one edge itself. And there is also another part to reach 2 from 0. That is 0 to 1 here and here, 1 to 2. Right? But I would have already visited. I will keep track of the visited nodes. So I will not visit this edge. Okay, since I would have already visited, I will not visit this particular edge. Now let's assume if there is no edge from 0 to 2 directly, then I need to visit in this way only, from 0 to 1 and 1 to 2. And while visiting like that, I need to check whether the edges are different. It should be in different color, whether it should be blue and red or red and blue. Right? I should not have two same colors at the same time. It should not repeat. So I should not have two colors repeating. In this case, I cannot have red and red. It should be alternating colors when visiting each and every node from 0. Right? That's what we are trying to do here. Now let's see how we are going to solve this. First, I've created the adjacency list to store the edges in the graph. So here from 0 to 1, there is a red color. So here 0 represents a red color and 1 represents blue color. Right? Then from 0 to 2, it is blue color. Then from 1 to 2, it is blue color. And also, in the question they have mentioned that the graph they have provided is a directed graph, right? Then I've created an answer variable where I'm going to return my answer. So first I'm initializing with -1. So if there is no path exists from 0 to that particular node, then I'm just going to leave it as -1. So here I've created an answer from 0 to n nodes. I'm initializing everything with -1. Then I have a visit matrix. So here, these are my nodes and these are my colors. 0 represents a red and 1 represents blue. I'm initializing everything as false. So this particular matrix will help me to check whether I have visited that particular node with the same color. So that's what we are going to check using this particular matrix. So since we are going to start from 0, I'm going to initialize the answer of 0, 0th index with 0. So this index represents my nodes from 0 to n-1 nodes. Then I'm also going to make these colors as true for the 0th node, right? So first I will code this particular part first so that it will be easy for you guys to follow with the code and the explanation. Then I will return back and explain the rest of the logic, right? Now let's see the code for the first part. So first I'm creating the adjacency list. So default dictionary list. Then I'm going to store the edges from both of my red edges and blue edges, right? I'm going to store that in my adjacency list. Since I have a dictionary of list, I will store it in a, I can append it directly. So 0 represents a red color, right? Then I will do the same for the blue edges. And I'm going to represent blue color as 1, right? Then I'm going to create the answer list for n number of nodes, and I will initialize the first index as 0, that is the 0th node, right? Then I'm going to create the visit matrix. So I will first initialize the red color and blue color as false, right, for n nodes. Then initialize the color of node 0 for both the colors as true, right? Now we will see the rest of the explanation. Then I will create a queue where it contains 3 values, right, in a tuple, and this represents the node 0, and this represents the steps I'm currently in, the number of edges. Then this represents the previous color, right? Will help me to track the previous color, since we need to have alternative colors. So this will help me to track that. Then I'm going to visit all of the edges from 0. So I'm going to pop this tuple from queue at the start. So node will become 0 and step is 0 at the start. Then the previous color is -1. Now I'm going to visit all the edges from 0. So first I will pick 1, 0. So that is my neighbor, and the color is 0 and the neighbor is 1. So I'm going to visit 1 from 0, and that particular edge is red color. So 0 represents red color. So I will check whether I have visited 1, and I will also check whether the previous color that I visited is red color. Now I need to check my visit matrix, whether I visited the same node with the same color. So I will go to my first node, right? This is my first node, and I need to check the red color. So it is false, so I can visit. And I also need to check whether my previous color is equal to my current color. If it is equal, I should not visit. If they are not equal, I can visit. So here they are not equal, so I can visit. Then I need to check whether I have visited 1 before in any other path. If I have never visited my neighbor before, I can check that in my answer. If it is -1, then I can set it to step +1. So it will become 1 here, right? Then I need to go to my visit matrix and make this one as true since I visited this node with red color. So I make it as true. Then I will add this neighbor 1 and step plus 1, which is I'm moving forward. So 1, so here 0, 0 plus 1, it will be 1. Then the color 0. So this will help me to keep track of the color. When I pop it again, it will be helpful for me to keep track of that. Then I need to check whether is there any edges from 0. Yes, there is 2 comma 1, right? This one. So 2 comma 1. So my neighbor is 2 and the color is 1. The neighbor is running in separate loop and the queue is in separate loop. So we are writing 2 loops here, right? Still my previous color is -1 only. I'm still checking the neighbors of 0. When checking neighbors of 0, my step was 0, my node was 0, my previous color is -1. So I didn't finish visiting all the edges from 0 yet. So I've taken neighbor that is 2 and its color 1. Now I will check the visit matrix. Whether I visited the neighbor 2 with the color blue. It's false. So I can visit. And I also need to check whether the previous color is equal to my current color. -1 and 1, they are not equal. So I can visit. Then I need to check whether second node has been visited or not. If it is not visited, I should make it as step plus 1, that is 1. So which means there is one edge from 0, right? Then I will add this neighbor in my queue, which is 2, where I can move from 0 to 2 in 1, that is step plus 1. So it is 1. Then it has an edge of blue color, that is 1. Now I need to change my visit matrix, that is the neighbor 2 and the blue color I have visited. So this will be true. Now I need to top the top element, that is 110. So it will become the node 1, step is 1 and the previous color is 0, right? Now I will check whether there is any edge from 1 or not. Yes, there is an edge from 2 to 1, right? So I will pick 2 and 1. Then I need to see my visit matrix, whether I have visited 2 and 1 combination. So second node with blue color I visited. So I'm not going to run this loop. So I'm going to pop the next one, that is 2 1 1. So 2 1 1. Now I need to check, is there any neighbor from 2? There is no neighbor, right? So I'm going to just come out of the loop. Then finally I will return this answer. It will be 0 1 1. Now we will see code for this particular part. So before we code this particular part, if you guys haven't subscribed to my channel, please like and subscribe. This will motivate me to upload more videos in future. And also check out my previous videos and keep supporting, guys. So first I will create the queue. Then I will initialize the queue with 0 node and 0 step and previous color as -1. Now I'm going to write a while loop. Then I'm going to pop the current node, the step and the previous color, right, from the queue. Then I'm going to write a if condition. If that particular node doesn't have any neighbors, then I'm going to Just continue. Then I'm going to do the BFS. I'm going to visit the neighbors, right? From the picked node, from my queue. Then keeping it as neighbor. So this will be my neighbor node and the color of that particular edge from the picked node from queue to the neighbor, right? Then I need to check whether that particular neighbor has been visited. I can use my visit matrix. And I also need to check my previous color is not equal to my current color. Then if the particular node is not visited, I mean the neighbor, which I can check using the answer, then I can make the neighbor as step plus 1. Then I'm going to make the neighbor node and that particular color as true, which means I visited the node with that particular color. Then I'm going to append the neighbor and the step from my current original node that I'm checking, then the color, then finally I'm going to return the answer. I think it's fine. Let's run the code. As you guys see, it's pretty much efficient. So the time complexity is number of edges plus the number of nodes. Thank you guys for watching this video. Please don't forget to like and subscribe. I'll see you guys in the next one. Have a nice day, guys.